Good afternoon, everyone, to SolarPower Europe's Solar Startup Awards 2022 finalists panel. My name is Michael Schmeler, and I'm the Executive Advisor of SolarPower Europe. This is always one of my favorite moderation events throughout the year, as we, as a jury, have the opportunity to learn about new businesses to accelerate our energy transition, which, and you probably all know, will be mainly based on solar power. Solar is very often the cheapest power generation source today. It's also the fastest growing energy source. But the truth is also that most countries' solar contribution to total power generation is still in the one-digit level. So there's quite some work ahead of us and some way to go. And we need to do it fast, not only from a climate change perspective, which has been a driver for the last years, but also from a geostrategic perspective, as is now clearly shown by the Russian invasion in the Ukraine, and in the resulting for us in Europe in energy price hikes and uncertainty about energy supplies. Who didn't believe it in the past probably has woken up finally. Energy independence from fossil fuels and uranium imports, SAP, is crucial for our all well-being. So any clever ideas, very welcome. Today we are having the 5th edition of SolarPower Europe Startup Awards. We launched actually with a focus on digital solar and battery storage, which we've expanded last year to any type of solar business, as we simply wanted to be able to look at and present the full scale and variety of solar innovation. And that includes not only fancy digital peer-to-peer solutions, but also exciting manufacturing solutions, for example, which is also very much of interest to us in Europe if we don't want to fall from one dependency into another, as solar is getting huge. And indeed, our 5 finalists have very different innovative offerings, from materials for solar cell processing to PV heat solutions, solar cooling in developing countries, and solar module building integration. Before I introduce the jury, please let me know what the winner will take home, although this has to wait for the final voting, which will take place next week during the Solar Power Summit in Brussels. So the prize is 5,000 euros. The prize was sponsored by Enerpark. The winner also takes home a free startup exhibition spot at the Smarter Europe 2022 in Munich. This is Europe's largest solar and storage event. And this goes not only to the winner, but to all the finalists. You all get 1 year of free membership at SolarPower Europe. So already congratulations from the jury side on this. Let me briefly introduce the jury before we start with the competition of the finalists. First, I'm very glad to introduce Stephan Willa. He's with the awards from the beginning. He's a co-founder, shareholder, and board member of Germany's leading solar IPP, Enerpark, which operates in the gigawatt scale. I don't know exactly how it is at the moment because it's growing so fastly. PV projects in Germany alone, but it is active on 4 continents. Stephan did his master thesis already in solar energy in the last millennium. I don't say exactly when it was, Stephan. And then he gained solar experiences in different roles in various countries. He worked for BP Solar for several years. I think that's when we got to know each other. Then he was for several years the managing director of Conergy in Asia Pacific in Singapore before he started his entrepreneurial life. Stephan is also investing in solar companies. And welcome, Stephan.
Thank you for the introduction.
We have with us also Javier Sanz Rodriguez, who's the thematic leader, renewable energies at sorry. Let's close this here. Okay. Okay, so let's start again. So I'm happy to introduce Javier Sanz, who's the thematic leader renewable energies at EIT InnoEnergy, the innovation engine for sustainable energy across Europe, which is active in education and startup support. EIT has seen an investment of over $500 million injected into almost 500 sustainable energy innovations over the last decade, raised 2.5 billion euros in investments, has over 1,400 alumni from its master's program, and supports over 330 startups. And Javier is looking at the startup part also. Very happy to have you with us, Javier.
Thank you, Michael.
I'm also very glad to have with us Angel Reinders. Angel, I believe the first time we met over 20 years ago at an ISIS conference in Jerusalem. At that time, Angel had just finished her PhD in solar, was a researcher at the University of Utrecht, and worked as an advisor to the World Bank. Fast forward and jobs as professor at Delft University, University of Twente. Angel is now professor of design of sustainable energy systems at the Eindhoven University of Technology, looking at something important what engineers in their drive for efficiency sometimes tend to forget. Angel, welcome.
Thank you for this kind and extensive introduction.
Okay, we have 90 minutes, so only 10 of that have passed. All 5 finalists will be able to present their business in 5 to 7 minutes each. Each presentation will be followed by a up to 7-minute Q&A. So that means following the startup presentation, every jury member will be able to ask around 2 questions. I think we shouldn't be too clear on this. And so the plan is actually to get 8 questions answered per startup, and then we hope to have provided the audience with a good overview to be able to vote. So let's start with the presentations. And just as an FYI, the presentation order is random and was decided on by our events team. We will start with Triple Solar, and Mark Hoff, development and strategic marketing consultant, will give the pitch. And Mark, the floor is yours.
Thank you very much, Michael, and thank you also for choosing Triple Solar as a finalist and give us the chance to pitch to you today. I'll try to fly through my presentation as the time is limited. Let's see if I can get the slides moving here. Triple Solar is a Dutch company. If we can go to the second slide. Basically, that has 2 products, a very smart solar panel, what we call a PVT panel, which is a panel that has a photovoltaic front and a thermic element at the back. And we have launched a PVT heat pump, which I would love to show to you. There we go. The mission of our company is basically we want to make impact in the world and make our products available and affordable to a broad audience. Basically make sustainable products that are fully recyclable, and that's what we do with these 2 products at the moment, and more products, sustainable products will come. Recent developments in the world have shown us the large dependency on the Russian gas, and what we believe is with our products it's very easy to reduce the quantity of gas used or remove the dependency of Russian gas in total. We can move to the next slide. So basically, most people know the existing solutions as sources for the heat pump. On the left, we see the outdoor units for an air and water heat pump. Oh, if we can go 1 slide back, which is actually quite a noisy source for a heat pump. It needs yearly maintenance, and it makes quite a lot of noise. What's happening with the slide, guys? The other source that most people know for the heat pump is the ground source. The ground source for the heat pump basically drills a pipe into the soils and leaves the plastic pipe there. It's not our opinion of being very sustainable. There you go, thank you. And now we can move to the next slide. So basically in the schematic overview that I'm showing you here, in the next slide, you can see the now 3 solutions that are available to you. So we believe that we have a new source for the heat pump, which is number 1. And so you don't need an outdoor unit which makes noise, or don't need the ground source anymore. We can move to the next slide, Michael. So our PVD panels are placed up on the roof. It basically uses both solar but also outdoor air temperatures as a source for the heat pump to basically provide your house with heating, hot tap water. You can actually use it for cooling as well, and we generate electricity that you can use for your heat pump. And we do this with our own PVD panels, which are very efficient. We have a seasonal performance factor of 5.6. So basically every kilowatt of electricity that you put in generates 5.6 kilowatts of heat. And this is one of the most efficient systems in the market. Our new triple solar PVT heat pump is also a very smart device that we designed from the ground up with PVT as a source in mind. It uses propane, which is a very environmentally friendly refrigerant. It works from -10 and can generate temperatures up to 70 degrees Celsius. So it is the perfect solution for also houses which are now gas heated. It's very compact, our new heat pump, and it's very light to install. We can move to the next slide, please. Here you see our first project, which we've just completed in the Netherlands with 93 new built apartments that have our heat pump and a water boiler and some expansion vats built on a skid. So those 93 apartments are now energy neutral and heated, cooled, and generate electricity with our PVT panels on the roof and our heat pump installed. So they're not dependent on Russian gas whatsoever. Your total solution to basically be off the grid. We can move to the next slide. I just want to show a couple other projects. This is a housing block, a new complex with 40 large houses that each have their own heat pump. And in total, we installed 280 of our PVT panels. We added an extra 400 PV solar panels to make these houses so energy neutral that they're actually generating electricity at the end of the year. So they have a positive energy bill. They get money at the end of the year. Let's move to the next slide, please. Now, not all houses that are existing in the world are ready to go off the grid immediately. They might take some time because they might not be insulated very well. And for these houses, we are proposing what we call the hybrid solution. So in 3 steps, you can start to reduce about 60 to 80% of your gas. Now, how does this work? Let me show you how. Let's move to the next slide. In an ideal situation, this is what it looks like, and we'll get to this in 3 steps. In the next slide, I will show you the starting position in most houses, where people have a gas boiler in their house. So the first step would be to add our triple solar PVT hybrid heat pump next to the gas boiler, and you install as a source for your heat pump 3 PVT panels on your roof. By doing this, you will start to save about 60% of your gas bill. Let's move to the next slide. If you have a little bit more money and saved a little bit, you can add a boiler for your hot tap water. basically increasing your gas savings to about 80%. And when you have maybe more budget, or when your gas boiler dies out because of its end of life, you can add a second triple solar PVT heat pump next to the first one, and they can work in cascade, modular, next to each other. This way, any investment that you make in our products are never lost. We call this our no regret solution. So you can build step by step towards an all electric off the grid solution, where you start with hybrid, and then each time you have a little bit more budget, step by step, you can move to completely off the grid. You can move to the next slide, please. So here is a few of our projects which you can see on our website. As my time is limited, I kindly invite you to look at our website. There is a lot of projects out there. Eat your heart out, I would say. And that's, if we move to the next slide, the end of my pitch. Sorry, it was very dramatic at the beginning, but hopefully I did not bore you, and I have explained our products very clear to you. It's not the end of it, it's the end of my presentation, but it's a new beginning. Thank you. Are there any questions?
Thanks, Mark. Yes, there are. So thanks for bearing with us. So let's see what we have. I will start and maybe with the first two questions. So when I look at your offering, so I'm in solar for almost 25 years, and I think that I remember that in my early days as a journalist, I looked into PVT, and somehow it didn't work out. The costs were too high, materials were although too complicated still to even those not so efficient solar panels at that time. So what has changed actually? So if you kind of really look over the last 20 years, what has changed and why is this now ready to go? Although PV has become, of course, much cheaper, and heat pumps, there's a big drive towards that. So where is the improvement?
Well, the improvement basically is a learning curve, basically from a product point of view. Also, the need for our products, of course, is higher. So we could do bigger volumes, driving the price down. Like with PV, we've really, went through a curve, a learning curve, and professionalized our products, which are now super efficient. And also with the current energy prices, our return on investment times are very acceptable. So you need to think about, 10 years ago, it was your return on investment of 15 years, and now we're looking at 6 to 8 years. So it's we're trying to make it very affordable for everybody now. And what happened overall is basically we fine-tuned our product in such a way that it is now scalable for very large projects, very efficient with the most modern technology that we can offer.
Okay, so maybe someone picks up and then I continue later. So.
Yeah, I would like to pick it up. I think really a great idea, as Michael mentioned already. So this combination itself is not new, but I think the combination with a heat pump, I think, is for me a very interesting combination. You mentioned that you have already a revenue stream. You showed some super interesting examples. But the question is, who is which of the installers are your clients? Is it more the electrical guy, or more the roofing guy, or more the heat pump guy? Because we all know these are in generally 3 different types of personalities or companies. So I think the challenge is probably to find the right access to the market. But please tell us something about this.
Yeah, no, you're absolutely right. The normal heating installer, of course, is a target for us. Currently, we do business with all 3 groups that you mentioned. It's the electrical installer wants to be sustainable, and his customers want to be sustainable as well and want to move off the grid. The heat installers, similar, they're moving towards innovations like our products. The biggest challenge we have is, of course, to find good installers. We are training installers on a weekly basis for free in our office, both online and in our office. And because of the high demand, there is a large need for more installers. But the interest of every installer, whether it's the guy that is focused on electricity or on heat, they are all very positive about our solution and eager to learn more about it.
Okay, thanks. Probably only one additional question, from a technology point of view. Do you manufacture these combination by yourself? So you take a module from an existing market and then you mount it to a module by yourself?
Yeah, we have our own factory. Basically, the PV panel is just a standard solar panel that we buy from Giese. We take it into our own factory and we add the thermal element to it in our production line, which is manufactured in the Netherlands. So we have a European supply chain, so to say. And the heat pump is made with a partner in Denmark.
Okay, good. Thanks a lot.
May I ask a question about the heat pump part of the system? Because
of course,
my background is in energy systems and solar energy, and I know that heat pumps in the Netherlands sometimes need extra support in the winter when there's cold months. And I just wonder, are the 4 panels that you suggest for a system of PVT panels in combination with a dedicated heat pump, which has been adapted to this system, will it be sufficient? Or would you require additional electricity in winter to run the heat pumps, such as happens with air and air water heat pumps at the moment?
No, it's a very good question. With our heat pump that runs on propane, the system with 4 PVT panels as a source is very efficient up to -10 Celsius. When it gets colder, the electric element in the heat pump basically kicks in. Now, in the Netherlands, on average, we've calculated this from our experience. It's about 43 hours every winter that this occurs. So you're looking at a couple of 10 or 40 euros extra cost on electricity over a whole year. So the Dutch winters are no problem at all. And that's, it's a very good question, because we do get the question very often. People are afraid that we can't heat a home in the winter. But the extra cost of electricity are basically compromised and compensated by the solar powers on top in the summertime. So you generate.
So my question was not about the cost, or it's more about the autonomy. So I wonder.
Yeah, no, so the heat,
because the system is promoted as a sustainable system, and more electricity you withdraw from the grid, the more likely it is that you use a grey electricity. But also on the other hand, the electricity grid has also become more sustainable. So it's not really a dramatic situation if electricity has to be withdrawn for 34 hours a year, because maybe in the future it will be wind power. And I have another question about PVT panels, because the system that you propose has been designed for Dutch households.
Correct.
Yeah, and Dutch households have a very specific energy demand. So what would this system actually need to be exported to Spain or Norway?
Well, good question. It's not specifically designed for Dutch houses, because we already export to Germany, to the UK, and to other countries as well. So we also export, for example, to Austria and Switzerland, where we see that snow is more of an issue than in the Netherlands. There we run a defrost program, for example, when snow is covering the thermal elements. But the system proves to be working very well in most European countries.
And then 4 panels would be sufficient, or would you need more or less panels in different parts of Europe?
Yeah, it's a good question. That depends, of course, on the size of the house, the family composition, if it's a large family, small family, how well insulated is the house. For a hybrid setup, 4 panels is enough, because you always have the gas boiler as a backup. If you go all electric, then of course, if you need more heating in your house, then you need a bigger heat pump, and then you need more PVT panels as a source. So we need to look at each house on an independent case by case. But we do have a lot of experience, of course. So we know if you have a 100 square meter house, you can use the 4 panels, and if you have a 200 meter house, then you need probably between 8 and 12 PVT panels and a larger heat pump, maybe 6 or 8 kilowatts.
Thanks.
Okay.
Thank you.
Thank you for the presentation, Mark. I think you managed the chaotic situation very well.
Thank you.
I have a kind of combined technical question. So the first thing is to, let's say, understand which is the temp you are getting out of the panel before you are getting into the heat pump. And then the second question is, as the heat pumps market is dominated by very big players, why you have gone through this self-design of the heat pump? What is making you different to the existing heat pumps in the market?
Yeah, good question. I didn't hear your first question, Javier, so I will start with.
The first question is about the exit temp at the panel itself.
It depends. The exit temperature depends also on the weather, of course. If it's cold outside, the exit temperature is a lot colder than in the summer. In the summer, the system is even more efficient. And we always take like a delta of 5 to 10 degrees between the in and the out temperature, and that's what we use as an input for the heat pump. And the second question is a very good one. We've developed this heat pump with PVT in mind from scratch. Now, in the beginning, we only had our PVT panel, and we used existing heat pumps like from Niebe and Metroterm and Nathan, for example, companies like that. But those were not designed with PVT as a source in mind. So we now went to one of those big companies. Metroterm is the one that we built this heat pump together with. But our R&D team worked very closely with the R&D teams of those big companies, so to say, and it's manufactured in their factory. But we own the IP rights because it was designed and thought out in our office with PVT in mind. So we built it completely from scratch, very efficient for our PVT panels as a source. For example, we can now heat and also cool by just switching a valve in the heat pump. So it's some very smart things. We can also make warm water with the heat pump itself. So it's a very smart device in a very compact machine.
Mm-hmm. Thank you. So I guess, just to be precise, this is a low enthalpy heat pump?
Sorry, this is?
It's a low enthalpy design?
What do you mean with low entropy?
A very low delta temp?
No, the delta, it can make up to 70 degrees Celsius. Is that what you mean? So it's a high temperature heat pump.
Okay.
Okay, maybe one. Sorry.
Oh.
Please go ahead, Mark.
Yeah, because of the high temperatures it produces, people don't have to change their convectors or radiators in their house immediately.
Thank you.
Maybe one final question, then we have to move on. In the questionnaire to the for this competition, you said you don't see any competition yet. Actually, we had three. We had three other, or in total, we had actually 3 PVT companies applying for the award. So we selected you. But nevertheless, so how do you see the competitive environment, and actually, how do you or how do you think you can grow actually and become a market leader?
Good point. I mean, fortunately there is competition coming. We see a few players in the market. We also look at efficiency of the output of their panels compared to ours, and as we speak, there are some tests now going on in official test departments from external companies that are comparing the competitors to our products in icy situations, etc. And the results look very good. we believe we can become the market leader because not only were we the first, but we believe the most experienced and the most efficient product. In the end, we cannot conquer the world ourselves. We need competition. We need help to take the world to sustainable heating. So we do welcome the competition, and it only drives us to higher levels of quality. And so we do welcome them, but we do not, see any troubles in the market from competition yet. Maybe that's explaining my answer a little bit more.
Okay. If there's nothing else, I think we move on. Okay, then thanks a lot, Mark, and
thank you
for your patience because of our technical
troubles.
You're
very welcome. Thank you.
Okay, great, thanks. Okay, then let's continue with the next presentation from Trygve Monstad. He's the founder and CEO of Giese Solar, and he will explain us what's so easy with his solution.
Thank you very much. I hope you can hear me well. Very good. Yes, so thank you very much for this great opportunity from SolarPower Europe. It's a pleasure for me to be here and to present our solution from Giese Solar. We are working with a unique solution for solar installations on flat and green roofs. And I'm especially excited today because this will actually be the first time that we ever expose our solution in a public event. We've been working kind of under the radar for the last year. So it's nice to finally be out there in the public. Solar modules have basically looked similar for decades. I mean, there's a lot of technology development happening in solar, of course, and especially, let's say, behind the glass. But the geometry and the outline of the module is basically the same. And especially for flat roofs, there is kind of no adaptation of the solar module for that purpose. Now, with bifacial solar cells, there is an opportunity to think differently. And we know that bifacial solar cells are going to dominate the production over the coming years. So our starting point was to take advantage of this development. So the solution that we propose is a modularized solution for solar installations on flat roofs. It's a patent-pending solution that contains vertically mounted bifacial solar panels together with the racking system, which gives very fast and easy mounting. And there are also multiple other customer benefits that I will show you shortly. So this is the first picture that we show you of our solution. We see it here straight from above. And because the solar panels are vertical, you see actually straight down to the rooftop below. If we turn around a little bit and see it from a different angle, you see here how it looks a little bit more in detail. So you see the vertically mounted bifacial solar panels and our racking. And in this solution, we actually have no need for ballast and no need for membrane penetration. And because of the modularization of the concept, it's very fast to mount, and we have demonstrated 10 times faster mounting than with conventional solutions for flat roof that consist of solar panels and racking systems and ballast. And then I'll show you some of the benefits and opportunities that this solution actually gives. Firstly, this is a great solution for green roofs, and we get what I would call full compatibility between solar power production and green roofs in the same space. As you saw in the first picture that I showed you, you see straight down to the rooftop below, which means that the plants below the panels will have access to rainwater and light, and there is like no conflict between plants and solar modules. And green roofs might sound like a small niche, but there are actually several million square meters of green roof being laid in Europe every year, and most of these roofs don't have any solar installations. And we hope to be part of changing that. Secondly, we have an opportunity to generate more valuable energy which sounds strange, but actually if we mount these panels so that there's one side facing east and the other side is facing west, we get 2 production peaks rather than 1 during the daytime. And these happen in the morning and in the evening time, outside of what you can call the peak solar production, where in markets with high penetration of solar energy, you have low prices and you have the problem of what we call price cannibalization. But producing at different times, we believe that the energy might have higher value, or we know that. But we can also combine 2 orientations like we did in this pilot installation that I show you in the picture. And if we combine 2 orientations of these vertically mounted solar panels, we actually get a very flat and long production curve from morning until the evening, which is great for buildings who want to self-consume most of their solar energy within the building. Thirdly, we have on our pilot installation that was installed this winter seen great performance during the winter time. One thing is, of course, that vertical panels are not covered by snow in the same way that conventional installations with more flat solar panels are. But actually, in the first period in February and March that we have installed this, or the first month of operation of our pilot plant, if we just had 3 days of snow, we had 100% higher yield during this period. And this comes from that the vertical solar panels are excellent for taking advantage of the sunlight when you have low angles of the sun in the winter time. Our business model is to develop this concept, manufacture together with manufacturing partners, and sell these solar units containing solar panels and mounting structure to installation companies, EPCs, electrical installers, and other contractors who want to build solar installations on flat roofs for buildings. We are a small team, but with a lot of competence. Together with Simona and Arya and me, we have about 20 years of experience with rooftop solar installations. And our business developer, Tommy, has sold about 5 megawatt peak of solar panels in units of 2 watt per solar panel, working with rural electrification and solar lanterns. So I think we have a good starting point. We have founded a little bit more than 1 year ago, and the last year we have been working with research, prototyping, piloting, and patenting our solution. And we are preparing to launch our product on the Intersolar exhibition in Munich in May. So I hope that many of you will come and meet us there. And while we are still quite small, we believe that we have a very scalable business model, and there's a lot of interest in the market for our solution. So we believe that we can actually take a small percentage of the global rooftop market with this product. We have strong support from many partners in Norway and Germany, and I would like to also especially thank our pilot customers, the Norwegian company ASKO, and the municipality of Oslo, for whom we are in about a month from now installing a pilot on a green roof. So I thank you very much for this opportunity again, and I hope to hear from many of the attendees of this webinar with questions, and please don't hesitate to get in touch if you want to learn more about our solutions.
Wonderful, Trygve. I think that's a cool solution. I like it. I knew it only so far from AgriPV. I think there were some vertical solutions like that. But maybe someone else wants to start this time.
Yeah, let me also probably start again. I think it was also difficult for us to judge you because you hide everything. So inside your pitch, you didn't show so much. It was a really challenge for us. Let's say I struggled a bit on one point when you say there's no ballast, which you need. I mean, correct me if I'm wrong. There is a system which you have to put on the roof, and the system has a weight. Yeah, and we have wind loads, we have snow loads, we have also the kilonewton, which are going directly to the roof. So why you don't need any ballast? Why you?
Well, it's of course we have a weight of our system in itself. It contains glass and silicon and aluminium, so it weighs about 10 kilograms per square meter, which is about half of the minimum for a conventional solar installation on flat roofs. But basically, the wonderful thing about this vertically mounted and small solar panels is that it self-eliminates the wind, so that the panels within the installation kind of shades the wind for the other ones. So you get some wind loads basically on the first panel of the installation, but the rest of the installation experience very little wind loads. And since the installation is connected together as a whole, then we don't see we see that there is actually no need for ballast. And the most important job of ballast in a conventional installation is to prohibit the system from flying up and blowing away. And since we have basically only vertical components, there is no upwards force that can lift up this installation.
Mm-hmm. Okay. Another question is, I mean, you manufacture them, the modules probably not by yourself, but I think it looks like a special module. So where do you manufacture it? Is it somehow a standard module, or how you manage this?
This is a completely customized module. We have manufactured now, or during the pilot stage, we are manufacturing now with partners in Spain and in Norway. But also when we scale up and start like serious production, we also want to find collaborations with other partners, preferably in Europe. We want to develop this as a European product, definitely. But we are looking for manufacturing partners on the solar panel sides, definitely.
Okay, thanks.
I have a question. I mean, the concept is simple itself, but I don't see which is the barrier for others to copy you. Because I guess at the very end you are, let's say, placing the cells in a shape of a panel, but the idea of putting them vertically is something that you cannot protect. So where is your competitive advantage? What is preventing others of copycating this solution?
Well, first of all, we have 2 patent applications that protect different key, I would say, concepts. I cannot expose exactly what it is because the patent applications are not public yet. But we have protected 2 key, I would say, solutions or points in the system through 2 independent patent applications. So yeah, but of course it's very easy to understand what the solution is about. It's not something we can pack inside of a box. So this is also why we have been a bit secretive and trying to get a little bit of advantage working this year on developing the concept. So we hopefully have also a head start if somebody wants to copy. But I've also learned during this year that it's not so easy to do something that nobody has done before. So I think we really will take profit from this year that we have working on this, like behind the closed curtains.
Okay, thank you.
I would like to express my appreciation for this concept because you seem to address a big weight bearing issue for flat roofs in, for instance, warehouses or larger utility buildings. So it's a nice solution, this. I just wonder about the risks related to the production of a customized PV module, because this is a very specific design. It probably consists of bifacial solar cells connected in a series, and this lamination in a facility in Europe. Is that correct? So you produce this in Europe or elsewhere?
It is produced in Europe. Yeah, that's right.
Yeah, that's nice about the whole idea. But what would happen if one of these modules would fail, and there's always reasons why modules could fail and have to be replaced, maybe in 8 years from now. So how would you deal with that situation?
Yeah, it's one of our key concerns. So we really want to develop a system that is possible to repair if there is some kind of damage to the modules. It's very important for the sustainability of our concept that it can be repaired. Of course, we have this modularization. So if one of the units have damage, it's very easy to replace a single unit, which is a small part of the system. But we're also, of course, working on finding a way that we can also exchange single panels if there is a panel damage on one of these small solar panels.
So how would you detect that? Because these are relatively small modules, huh? And there's many modules in one array. So how would you detect that one of those is failing? Would you do something with smart technology, or just check all the modules, the whole array?
Well, there are many companies, I think, working on smart ways to detect failure in modules, and that's yeah. I hope those solutions will also be applicable for our installations. But yeah, it's basically the same challenge with conventional solar modules. Also, it's hard to discover the failures in a single module anyway. So I hope there will be good solutions for that in the future. I mean, IR imaging from drones and these kind of things are developing quite fast.
Okay, thank you.
Okay, very interesting. I really like it. So I'm still interested in the cost part of the system. So you probably have made some assumptions. Of course, at the moment, you're still small and it's very difficult to compare it to a standard module. But first, if you were in a gigawatt scale, what do you think is the cost comparison to a standard module? So from a CapEx side, and the second would be also, you probably also looked at installation time. How much faster or slower is it if you compare it to a normal system? Maybe third, I would be also interested to see you specifically emphasize self-consumption. I personally think that especially if we think about the energy transition, this is not about self-consumption. We have to put as much solar on the roofs as possible. So that means we have to cover all the roofs. It's not just about certain parts. If you look at a flat roof versus your solution, actually, how much more or how much less comes out of that? So, and I think we have to compare apples to apples, actually, maybe also get a white roof and also take a bifacial standard roof, for a standard panel, for example.
Yeah, thank you very much for very good questions. Firstly, about the cost, as you said, we're now on the piloting stage, and it's very hard to compete with the cost when we're manufacturing customized solar modules on a small scale. But in principle, the components that we put into the production and the materials we use are the same as are being used in conventional module and racking production. And if you look at the costs from a regular module production, it's basically material cost that goes into the equation. So that tells me that we are in the future, we're going to be very competitive about this, because we also, as you said, we reduce the installation time. We make the logistics also very much easier when the installer only has to deal with a single supplier instead of ordering panels from one supplier, racking systems and ballast, and has to fit all this together. So I think cost competitive wise, we will be in a good position in the future. As it comes to self-consumption and the energy transition, I'm also with you on this, and of course I have to be honest that I think our weak point is probably that the amount of kilowatt peak that we can pack into a certain amount of square meters is lower with this solution than with just laying flat modules on the rooftop. So this is something that we need to be aware about. Of course, especially when we have white roofs, we get an extra production so that we catch up a little bit and we get closer to the amount of energy that can be produced with a conventional installation. But it's also another thing about this is the sustainability on a lifetime perspective, and that's one of the things that we really enjoy about the system, is that it's very easy to maintain the building, the roofing material itself. It's easy to inspect. If you have a leakage, to find the leakage, you can easily take away certain units and modules to repair a local leakage. And even if you want to change the whole roofing material, you can easily also take away and stack up and put back together the solar installation afterwards, which I think is going to be very difficult with the conventional solar panel installations that are mounted together. You have to dismantle the whole installation, let's say 15 years after that it was installed. I think the sustainability that we will see in that situation is going to be a problem in the future.
Okay, super. Thanks. I think we have to move ahead time-wise. Thanks again. And
thank you. Thank you for very good questions and for this opportunity.
Okay, then we move now to manufacturing material. Marcus, welcome. What's yours?
Yeah, thank you. Okay, thank you for the introduction, and yeah, thanks for being given the opportunity here to pitch, because really SolarPower Europe is maybe the most important network for us, and so we're really grateful for this opportunity. And so let's see. Oops, cannot switch the slides yet. No, okay. Yeah, so the problem that we didn't want to continue. Maybe someone else can go to the next slide. Ah, okay. Now it goes too fast. Okay, so the problem that we as a startup want to solve, that silver used for the electrical context of solar cells is scarce and it is expensive. Now, expensive, you can say this is not a major issue, as solar is the cheapest way to generate electricity already. But the real problem is that there is just not enough silver globally available to scale the solar industry to a level where we can reach our climate goals. And this is not a problem in the far future. This is a problem that will be really massive in the next 3 to 5 years already, according to industry experts. So the problem is even worse for the European solar industry. We want a solar industry, a solar manufacturing industry in Europe, because we want also energy security, and for that we need also safe supply chains. And Europe is not producing a lot of silver because we don't have this resource very abundantly, and we will have to rely on other overseas countries. And this is not a good situation by itself. And then the European industry also strongly bets on the heterojunction technology, which is a really interesting, also a good choice. It's a good technology because you can reach very high efficiencies, and you have a low CO2 footprint with this technology. But you have silver on both sides of the solar cell, and so we have a higher demand of silver for these solar cells compared to the standard technology. So we were really looking to solve this problem specifically for the heterojunction technology. And so next slide, maybe. And so our solution is to substitute the silver with copper using a patented electroplating process. And by that, we can already reach today a significant cost reduction, because silver is, or copper is 100 times cheaper than silver. And also we can reach a secure material supply also in the far future, because copper is 1,000 times more abundant than silver. And so even if copper is also a scarce resource, this few grams in a module will not make a difference. You need to do additional investments to implement our technology, but we calculated that the payback time is less than 1 year. On top, you get a higher performance, because the electroplated copper is 2 to 3 times more conductive electrically than the printed silver on heterojunction solar cells. And finally, also, I think more and more important is that our technology is is more environmentally friendly, because the mining of copper is by far less detrimental than the mining of silver, and also the process itself is more environmentally friendly, because we don't have emissions of hazardous metal particles or organic solvents, which are a hazard for the operators in the production as well as for the environment. So next slide, please. Or I don't know if okay. So our business model is that we as a startup offer our technology to the manufacturers of solar cells, and we offer support with the implementation of the technology and the maintenance in production with our workforce and our know-how. Also, we give a license for using our technology, because this is patent protected. We do not want to offer this alone, but in a joint venture with tool manufacturers and material suppliers. And so in this way, the solar cell manufacturers get a kind of turnkey solution for the contact application on the solar cells from us, and minimize their own effort and risk. Next slide, please. So our advantage as a startup is that we are sure that we have the best technology to substitute silver on heterojunction solar cells, considering the costs and the sustainability. We also we are a startup from Fraunhofer ISE, which is the largest solar institute in Europe, with close contacts to the industry, and as employees there, we take those contacts with, and we already have signed letters of intent from partners for the joint venture and potential customers. We have a granted patent, and what is also very important for a startup, we have, in my opinion, a really good team. We are broadly skilled and experienced. You see the team on the next slide. We are 4 founders. We have all a different professional training and also work experience in industry. And by that, I think we complement each other really well to make this a successful startup. The next slide, please. So with that, I also want to thank all the institutions that supported us that far, and I also thank you for your attention, and I'm happy to take your questions.
Thanks, Markus. Very nice pitch. Who wants first?
Yeah, let me probably also start again. I think number one is I think you've been also with us last year, and we are very convinced that this is really a super interesting idea. And we finally looked in the last 12 months and some, I don't know, newsletter, MOU signed with. So on the other hand, we all know that the the processes are very well thought through of all the manufacturers, so they are generally a bit hesitant to change something. But can you give us a bit, I would say, a bit an inside view why you don't see the breakthrough? Because for me it sounds all logical, yeah. And so what is the reason why the main manufacturers are a bit hesitant to make such a decision?
Well, I think we work on this for quite a long time, and until now we didn't have that breakthrough. But we have an exponential curve of the growth of the solar industry. And it's like with COVID in the beginning, you can already estimate that in a few years there will be a huge wave. But and also this is the same with the silver consumption. We have the ITRPV, the International Technology Roadmap, that shows us how we estimate how we can reduce the silver usage per watt. And we have scenarios how the solar industry will grow. And you see that, as I said, in 3 to 5 years, this will clash. There is a big problem. And I think now, that's also why we made the decision. We want to do a startup now, because now is really the right time. The industry is noticing that this problem is coming, and depends on who you talk to. If you talk to Pierre Verlinden, Pietro Aldermatt, who are really well-known experts in the field, they really say we are too slow with developing these alternatives with copper. And I think we are really here at the right time. This is really the window of opportunity is now opening.
Well, I believe it is, because I think Michael and we want to avoid the strange discussion with our people who criticize the energy transition, because everyone comes with the argument, oh, you cannot think in terawatts because there is only 500 tons of silver available in the world. So. And I would love to say, forget guys, because I just checked that it's 800 or 900 million tons of copper available and generally around the world. So if we calculate this factor in, then we don't speak about terawatt, we speak about, what is the next one, petawatt?
Petawatt, yeah.
So really, I wish you really all the best. But again, I think it is a technology topic. It's not easy to sell. It's not a product which is B2C or B2B. So really, thumbs up to you.
Thank you. Yeah.
Yeah, I have a question.
My question, Marcus. Sorry.
Yeah, sorry.
Yes,
I have a question about technology that you've chosen for the copper screen printed contacts, because silicon heterojunction solar cells are at present not actually not making the large share of the solar cell market. So what are your projections for the future, and how big will this market become in, let's say, 5 years from now?
Yeah, I mean, one reason why heterojunction didn't take off yet after the patents of Sanyo were not, how to say, when their IP wasn't protected anymore. One reason was definitely the silver. We talked a lot with the industry, what's the problems, and silver consumption is really one of the major problems. And so, I mean, there are a lot of announcements, like Taiyang estimated that maybe 2 years ago that we will have 50 gigawatt production, or at least is the sum of the announced capacities all over the world. And I think this is really happening, maybe not always everything in time, but in Europe we see that there is really a strong dynamic towards the heterojunction.
Mm-hmm. Thank you. And I have another question. So if this will happen with the heterojunction solar cells, then what's then the chance that copper will be applied more in other types of solar cells?
I think it has to happen, because this disadvantage from using more silver will then turn into an advantage of using no silver. So others will have to adapt with the PERC technology. This is today's standard. This is, I would say, today quite easily possible. But the thing is that we see that PERC is really coming to its limits, and so no one wants to invest now into this new back end. They all say, okay, what's next? Either TOPCon technology or heterojunction. And I think for the industrial application, we are actually ahead with the implementation of the copper contacts on the heterojunction. On TOPCon, there are additional challenges. Even though we are also developing or thinking that we can also transfer our process to TOPCon if we modify
because
it.
TOPCon would be similarly interesting in the end because it's also requiring more silver. So what's the issue with TOPCon? Because if you manage that, then you any next generation technology would be in your scope. Huh?
Yeah, definitely. It's true, but with TOPCon you usually have dielectric surfaces, and you have to somehow contact the silicon underneath the dielectric. And with heterojunction, you have a conductive surface. So the concept is a little bit different, but we have a plan how we can also implement our technology on TOPCon. TOPCon has also with the plating process itself, it's just a little bit different there. Yeah.
Can you just also shine some light on actually the production equipment changes, CapEx-wise, what's needed there actually for your process? So when one switches from silver to copper, I think, you know, there has been some trials also in the past. Actually, I think the reason the Chinese didn't go to copper was actually environmental reasons, because there are some solutions actually that was not closed loop. And that's why some of the municipalities actually said we don't want to go to copper because that's not easy to control. So maybe you can.
Exactly. I mean, I think it is a lack of trust in the manufacturers in that area. Where they had a lot of printed circuit board industry that they would really contain all their wastewaters and really have no emissions into the already polluted water there. I think in Europe, this is much better manageable. We have strong control of such emissions, and this is, I think, very well doable. So, sorry, I forgot already the first part of the question.
Yes, yeah, I think, but the question is actually, so you address basically then the European market. So first, and yeah.
We would
because in the end, actually, of course, you have to convince also the Chinese at some point because that's where the big market is in the end, right?
I hope this is not true for the next years, that we really have strong efforts to bring back manufacturing, and we have to, I think. But of course, if this isn't happening, we have already close contacts with solar manufacturers, with solar cell manufacturers in China, but also with the IP, this is a lot easier. So it's also, we would love to stay in Europe with our technology, at least in the beginning, because the IP protection is a lot stronger in Europe or the US.
Okay, and then the other question was regarding equipment, actually. What changes is
yeah, exactly, yeah. So, I mean, we would get rid of the screen printing lines, which is not big capex, so that doesn't bring much of a benefit. Also, the furnaces, that is for heterojunction, the curing of the paste is a little bit more effort than we know from standard technology. We don't need that. And instead, we need an expanded PVD tool. We have already PVD for the TCO deposition, but we would need additional targets because we don't use a polymeric masking material as is standard for the plating on heterojunction or in the PCB industry, because we learned that this is really the weak spot of plating, this organic materials, because you will have later you will have problems with the wastewater treatment. So we use an aluminum layer as a masking layer for the deposition, and this will not cause a lot of extra costs, but then we have a laser to pattern the aluminum layer and a plating tool. So these are the two tools, and probably the greatest invest change or the greatest invest you have to do is into the plating tool.
And for a new line, that means actually, is it cheaper or more expensive?
The invest is more expensive, but it will pay back within 1 year, because it's really a huge amount that you pay for silver every year.
Okay, thanks. Javier?
No, I think all the questions were made. You were faster than me. I agree with Stephan that this is needed in the sector, so eager to see how it evolves. And I agree with your questions on the way to market, because I mean the heterojunction is going to be part of the market, but it's not going to be the total market, and how this applies to other technologies is going to be important as well.
Yeah, would be also great if you succeeded, because I think there's no paste manufacturer actually left. I think there's one, but it's also not producing in Europe. So, yeah. Okay, thanks. Let's continue. I think we're running a little bit behind because of our technical glitch. Okay, next speaker is Dismus Kizuli. Please go ahead.
Hi everyone, can you hear me?
Yes.
So can you present the slides, please?
Sure.
Hi everyone, my name is Dismas Kisilu. I'm based in Kenya, and my organization is called SolarFreeze. So next slide, please. Yes, I'd like to introduce you here to Grace, Mwende, and Dunge. Together, they are small-scale farmers based in rural Kenya. They primarily grow fruits such as mangoes and avocados, as well as vegetables such as kales. But they have one huge problem. Every season, over 50% of what they produce goes to waste even before it gets to the market. And this is not only their challenge, it affects over 500 million smallholder farmers across developing countries because they lack access to preservation and cooling technology. Next slide, please. So what does SolarFreeze do? SolarFreeze provides cooling as a service, so it's similar to an Airbnb for storage for small-scale farmers, and they pay as little as 0.1 cents, that's in euros, so that's around 10 Kenya shillings to preserve a crate for a day. And that simply means that we have now taken cooling from a product to now become a service for small-scale farmers through making it sort of like an Airbnb for storage and cooling of fresh produce and vegetables. Next slide, please. So the market segment is really huge. So in developing countries, over 310 billion of fresh produce goes to waste even before it gets to the market. This is because a lot of cooling technology is very expensive, and the technology is non-existent for farmers in very off-grid areas. Next slide, please. So I give you a good example of how SolarFreeze is working with small-scale farmers to help them access better markets. So a good example is the potato value chain, whereby in January this year, a 90-kilogram bag of potatoes was going for around $20, and it's a very good candidate for preservation and cooling, because you see in countries such as Ireland, whereby potatoes can be stored for over 9 months, and they get to wait out the glut in the market. So SolarFreeze works with the smallholder farmers, whereby they produce at the same time, and then we get to store for them, and then they can wait out the glut in the market, and the price can increase from $20 US to at least $75 US for a 90-kilogram bag. And also this reduces the glut in the market, whereby if they produce at the same time and they sell at the same time, we get to stabilize the price. It's sort of like a receipt warehousing system that is managed by SolarFreeze through the solar-powered container system. Next slide, please. So our product is a large walk-in solar-powered cold storage. So this is the size of a 20-foot shipping container, and it can fit over 400 crates of various produce such as fruits and vegetables. And we get to store this on a daily basis, whereby, as I mentioned earlier, the price is 0.1 cents, that's in euros, and or 10 Kenya shillings for a day. That's really affordable for smallholder farmers. And we work with groups and cooperatives to get them to store their products inside our solar powered units. So SolarFreeze owns the IP, and we are also the ones who develop this product and deploying it across Kenya. Next slide, please. We also have small solar powered chest freezers, which are ideal for the dairy and milk and fish sector. And they are fully solar powered, and they also have the same business model, whereby the people using them get to pay us on a daily basis, and we collect the money using the mobile phones and through M-Pesa, which is the mobile money transfer system. Next slide, please. So we use data in terms of IoT that can get us the exact temperature of our units. So if in case there is any fluctuation in these units, we get to send a technician on the ground, and then they get to troubleshoot the units. And we also use market access data to help the farmers know the best price that is prevailing in the cities that they don't have access to. So we connect them to large retailers and large supermarkets through our mobile app that we have made in-house. Next slide, please. So our competitive advantage, as I mentioned earlier, is pay-as-you-store business model, whereby the farmers don't get to own the technology, but us as SolarFreeze get to own it. And as I mentioned earlier, we have a large 20-foot container unit that is made fully of solar powered, and the technology is fully solar powered, whereby we are based in an equatorial environment, so there are 365 days of sunlight, and there's no challenge in terms of energy access. So we also help the farmers increase their sales by connecting them with better markets, because we aggregate the produce inside one container, and then we talk to the larger supermarkets in big cities so that they can take the produce in bulk. And then we offer cooling as a service, which is eco-friendly, and which guarantees that they have eco-friendly cooling for their produce, and also steady supplies for the large markets, whereby we guaranteed year-long supply of various seasonal produce. Next slide, please. So our impact so far, we have worked with 3,000 small-scale farmers in Kenya, helping them reduce post-harvest food loss by at least 95%. We also have an internal training program, which we call Each One Teach One, because we noticed that in all the areas that we are deploying the SolarFreeze technology, there's a lot of interest from young people in terms of renewable energy. So it's sort of like a peer-to-peer training program, whereby university students get to train rural young people in terms of basic maintenance, repair, and operation of the technology. And after that, it's normally a 4-month program, whereby if they're mostly on a gig economy. So if there's any challenge with the SolarFreeze technology on the ground, they can get to fix it. And so far, we have worked with 100 young people in terms of this training program, and also helping to deploy at least over 20 solar powered chest freezers and more than 100 large walk-in solar powered units, which have gone on to serve over 7,000 consumers in large cities, providing them with safe and nutritious food, which has been guaranteed in terms of preservation and cooling, as well as providing adequate cooling for them. Next slide, please. So a major impact has been in terms of reducing post-harvest food loss and waste, which is a huge challenge. As I mentioned, more than 50% of what is produced goes to waste even before it gets to the market. So SolarFreeze has essentially cut this down to at least more than 95% through our solar-powered service, as a solar-powered cold storage as a service model. and working with more than 3,000 smallholder farmers. Majority of them are women, and we have been able to increase their income from 50 US dollars per month to at least 350 because they can get to access better markets and store their products for longer. We have also introduced the franchising model in areas where independent businesses can own the solar-powered refrigeration system, and then we provide the technology behind it. So we provide the IoT technology, and also we provide the large solar-powered cold storage and provide the payment for them, which enables more franchises to own the solar-powered technology in terms of independent businesses. Next slide, please. So as I mentioned, so far we have deployed well over 150 solar power chest freezers, and one unit of the large one cost us at least $4,000 to deploy. We are the ones who fully deploys the unit, and we customize the unit based on our client preferences. And the temperature can range from -4 degrees to at least 10 degrees, which is ideal for a lot of vegetables and fruits, and ideal for the dairy sector, such as storage of milk. And we hope to expand this technology because we have realized that post-harvest loss affects over 500 million smallholder farmers, and most of them are based in Africa. So we see a huge potential. Right now we are only in Kenya, so we want to expand this technology across East Africa and across other parts of Africa, hopefully in the next 5 years to serve at least 5 million smallholder farmers with our solar-powered cold storage technology and innovation. So thank you so much for your time, and I look forward to your question and answering them as well. Thank you.
Thanks. Great idea, great solution, very helpful. Who wants to ask first?
Yeah, let me start also again. So I think we have now a standard rule of questions, but I think it's fine. Yeah, so really very interesting. Can you give us a bit more information about the business model itself? So because is it that the farmers are paying, I don't know, cooling service per day, per kg, or how you generate, I would say, a revenue?
Yeah, sure. So the business model, we normally charge on a crate basis. So our units are based mostly at a farmer's market. So at the end of the day, after they sell their produce, they need somewhere to store. So in most of developing countries, farmers' markets are open air and they lack access to cooling and preservation. So at the end of the day, they bring their produce in a crate, and then that's what we charge 10 Kenya shillings. So one 20-foot container can fit at least 400 crates, and we charge only 10 shillings for this. So we break even for one unit within a period of 1 year, 4 months, based on capacity utilization of at least 70% utilization. So I'm happy to report that in terms of the technology, we've worked with MIT University to make this technology, and we collaborated with them to come up with evaporating cooling technology so that we can reduce the cost. And this is a pioneer technology in terms of refrigeration and cooling, reducing the price for smallholder farmers in terms of access to cold storage.
Okay, thank you.
Yes, thank you for your interesting presentation. I have a special interest in your work because I have been involved in remote electrification in the past. And for that reason, I also understand what the significance of providing electricity-based services to remote areas, for instance, in agricultural areas in Africa. So also, I would like to, I don't have any doubt about whether this technology works, because we also have solar-powered fridges for vaccines, that sort of thing. So that all works. But I would like to talk about the business idea and the business plan, because I want to know from you, as a developer of the whole business, whether this is more a technology-driven innovation or a service-directed innovation. And want to know where is the possibilities for growth, either in the product or in the services.
Yeah, sure. That's a very good question. So before we started this work, my background is in renewable energy as well. I studied engineering in renewable energy. So at first I thought it was a technological issue. So we had a chance to work with MIT University to reduce the cost of this technology. So as you're well aware, cooling and refrigeration is very expensive, and a lot of rural communities whereby their primary business is in agriculture, they are not able to afford such technology. So initially we wanted to reduce the price of cooling. So that's when we came up with the evaporating cooling technology, but powered by renewable energy. So that effectively reduced the price of this 20-foot container all the way from at least 25,000 US dollars all the way to 6,000 US dollars. But in terms of how we have been able to scale successfully, we have taken up the technology and deployed it ourselves on the ground. So we fully own the solar powered units, whereby we deploy them and then we charge them on a service model. That's what has been the success for us. So I think it's a two-way answer, whereby initially it was the technology for us, reducing and coming up with new cooling technologies that are environmentally friendly and also cheaper. And we realized very quickly that we also need to prove the business model by making it more of a service rather than selling the technology, because a lot of small scale farmers don't have access to maybe credits from banks or organizations that can lend to them, but they have the daily income in terms of the cash whereby they can pay as a service model. So that's when we came up with a pay per day use case, which has been very effective for the vegetable sector as well as the fruit sector, which need a lot of temperature control. And this also gives them an alternative in terms of they can now wait out the glut in the market. So the challenge in most of these rural areas is that they tend to produce the same product at the same time. So there's normally a market crash. But right now with solar freeze technology, as I mentioned earlier, with a good candidate such as potatoes, they can wait out that glut and the price can stabilize in the market. So for us, we think of ourselves as a technology company that is mostly now doing in the business of providing cold storage as a service. But in the future, once we expand to other African markets or in other markets across Africa, we think of ourselves mostly as a technology company because we have already figured out the technology behind this. So mostly we are going to be providing that technology, and other people are going to run it. And we provide the IoT, we provide the maybe the installation and how to plug and play the technology, and also the payment system behind it. So I think it's a two-way answer, because right now we are in very early days of this technology and deploying it in Kenya, which has received a lot of traction. We are doing both of those things, but in the future, once we scale, maybe in the next 2 to 3 years to other countries, it's going to be mostly a technology company.
Okay, let's maybe quickly, we're running a little bit late. This was, so I think Javier, one more question, Javier? Where's Javier? We lost Javier. Okay, so then maybe a quick question from me. So tell us about actually how you want to scale actually. So because you have these and how you finance actually investing into this products actually. What is your business plan? Where do you want to be in 3 years, and how do you finance that and organize that?
Yeah, sure. So we received an early on investment from Enel Energy Group. So that investment helped us to scale our technology. But in terms of increasing our impact on the ground to other countries, where we have received a lot of inquiries across the board, mainly in countries such as Ethiopia, Tanzania, Rwanda, and we want to scale that by offering the solar freeze technology through a debt service. So scaling for us, because we have already proven the business model, right now we are ready to take on debt investment, because we we have proven that our business is profitable, and we have figured out the business model behind it. So scaling for us looks like that, and we are looking for more data avenues to scale our technology. And we see a lot of potential across various agricultural sectors, such as the vegetable sector, the fish sector, as well as the fruit sector.
Okay, Dismus, I think that was great. Very interesting and very important thing you're doing. Cool. Okay, let's go to the last one. We're really late, and see what we have on offer now. Next speaker is Michael Giese. He's a marketing manager at SolarStone, and we're back to solar and buildings. Michael, it was yours.
Hi, thanks for the intro, Michael. So my name is Michael Giese, the marketing manager at SolarStone. It's a prop tech company based out of Estonia. Next slide, please. In a nutshell, our core business is building integrated solar roofs. We produce different types of in-roof solar modules, and at the same time, we have developed a custom framing solution to turn regular solar modules into two-in-one roofing material. Our goal is to make top quality BIPV roofs a mass market product and develop the best tools for solar community. Next slide, please. Yes. We have a strong team of experts from the civil engineering and roofing industries, and people working closely with start and scale-ups. We also have seed and Series A investor on board, and the cap table is rather clean. Next slide. So what's wrong with regular rooftop solar? First, standard rooftop installations have double layer roofs, which results in wasteful use of roofing materials. So only about 2% of roof embedded solar roofs are really following the green agenda. Second, there are no good tools for building integrated solar out there, which hinders the opportunity for BIPV to become a norm for the construction industry. And third, BIPV has been a niche product, and regular solar installers do not like it since it's too complicated to install. Next slide, please. How is SolarStone changing the game? Our BIPV solutions require 2 times less material. We develop easy and functional software tools for solar community, and our patented technology makes it attractive for potentially 10,000 solar installers in Europe alone. Next slide, please. A little bit about the product. SolarStone tile interlocking solution has been out on the market for a few years and has had the most success in terms of volume. But the click on full solar roof solution, the one on the right side on the slide, has the highest potential. It's a truly scalable solar roofing product. In essence, every standard solar module can be instantly converted into weatherproof roofing product with our custom framing solution. Next slide, please. So the click on framing kit includes 3 aluminum profiles that are fitted around a standard solar panel. So for example, Longi JA Solar, and thus a 2-in-1 weatherproof roofing material is born. It's one of the most affordable solar roofs out on the market, and the product has won many awards over the past year. It's perfect for residential and commercial use, as well as solar carports, solar PVC halls, and solar facades, which is actually missing from this slide. Next slide, please. SolarStone is not just a hardware company. We have built a powerful digital toolset for automated layout planning and coding for resellers, partners, and our sales guys, as well as 3D BIM models for architects. And we are currently building a virtual power plant to connect all SolarStone solar roofs into one platform. Next slide, please. Over the years, we have partnered with major players in the industry, such as BMI Group, which is the world's largest roof tile producer, and also Svea Solar, which is Sweden's largest solar solutions provider. Next slide, please. Of course, we are not alone in the building integrated solar business. but our solutions stand apart in terms of affordability and ease of installation. And these are really the two big instruments that help make in-roof solar go big. Next slide, please. Little bit about the trends. The EU is and will heavily invest into improving the energy efficiency of the existing building stock, and at the same time is encouraging all new builds to follow near zero emission standards. And based on modest estimation, by 2030, we are able to generate 200 million euros in revenue and keep net profitability around 30%. Next slide. Our track record has been quite outstanding. We have completed over 550 solar roofs, and we continue to grow 3 times per year. COVID did hit our expansion plans quite a bit, but we are currently entering major European markets, so we continue to triple the revenue annually. And our resellers and distributors in 10 plus countries have indicated that in 2022, we are able to boost the revenue up to 6 million euros. Next slide, please. This is SolarStone in 2025. We are looking for ways to bring manufacturing outside of Estonia and establish fully automated manufacturing units close to our customers. And at the moment, we are setting up organizations in US and Germany. Next slide, please. We have just raised Series A funding to support the rapid growth, but since it's very fresh and no official communication has been released, I cannot disclose any more details at this point, but do keep an eye on us in the next few weeks. And the goal for this year is to expand our team to 50 people, complete certification processes, and further invest into automation of sales. Next slide. SolarStone's vision is clear. We want to become not only market leaders in our home market, the Scandinavia, but the whole world. Thanks for the attention. This is SolarStone, the solar roofing company. Yes, and happy to take any questions.
Okay, thanks, Michael. Very interesting. Stephan, you start again?
Yeah, I mean, really interesting. I've seen it also a few times in the news, so I think it's cool, and especially I think we all have a challenge right now in Germany. There is a PV duty on new builds, and there are still a lot of people who doesn't like solar because it's a retrofit system. And even in the past, I thought about, come on, it's better to do retrofit, it's faster. No, I think we need this now. We need a nice solution. One main question is now, I think you started, correct me if I'm wrong, a bit as a solution provider, but now you are a bit a product provider. How you manage this transition, or is it also your plan? Because you mentioned also about 60 partners already globally. So how you want to achieve this quite significant growth?
Mm-hmm. Yeah, we actually started out with one product, which was tile interlocking solar module, which was meant for tile roof, and one module replaced exactly roof tiles. But that kind of set the limit for us, so we could only manage to build, solar roofs that had tiles. So from that, we grew out into, I think, 2021 or late 2020, when we came out with the ClickOn. We were looking for ways how to make solar roofs affordable and how to scale it up fast. And how to do it is not to make the panel itself, but to make the panel into roofing material. That's when we came out with the ClickOn framing kit. And this is a very easy product to scale up. It's a very easy product for the partners to understand. It's very easy to transport because you only need the frames and like the aluminum profiles. So it's I think it's like quite essential for the partners as well, and it plays a very important role in the growth of the company.
Good. Yeah, really interesting. I think the challenge is probably really to find the right partners, no? And the right distributors for these products. because there's also, I would say, always a challenge if you mix two segments together, and one is the roofing guy and one is the electrical guy, and both, I mean, the roofing guy don't want to touch electrical stuff and the electrical guy don't want to touch the roof. So I think try to combine this, and for me it looks like a cool product now.
Mm-hmm. Yes, thank you. And indeed, it's one of the biggest struggles for us to validate the correct partners. And as you can see, I'm doing this pitch from the car because I am actually in Riga in Latvia at the moment at an exhibition. So we are trying to activate the Latvian market at the moment as well.
Good, excellent. Yeah, I wish you all the best.
Thanks.
Yeah, so I would like to express my appreciation for this really smooth and also well graphically designed PowerPoint. It looks really good, and it gives also a few good moments in, let's say, in a world with ugly PV products. So this is probably a game changer. And what I like about it is that you don't want to introduce what they call weirdo colors. So you just focus on integrating your product in or blending it in the existing architecture in probably dark grayish colors that you have in Estonia and elsewhere. So I don't have any comments on the aesthetics, but I wonder maybe there is also issues that I would like to ask questions about, because definitely there are issues because it's a new product. And I just wonder, what would you do if the let's say the integration of PV is not developing as rapidly as expected, because there's high expectations at the moment. But seriously, if you look at how big the market for BIPV is, then it's just a few percent of the total market. So what can you do about that? Because there's still that reluctance to integrate electrical technology in building envelopes.
Yes, good. That's a very good question. I don't think there will be a lack of demand for BIPV solutions in general. It is actually very comparable to regular on-roof solar installations in terms of price, especially if you compare new builds. Because if you have a new build, you would have to pay for the roofing material, the installation of the roofing material, then the solar modules and the installation of the modules. So you have a double of everything. With building integrated solutions, you pay only once. You have two-in-one. You have the roof and the panels at the same time. So in many countries in Europe, like for example Norway and Denmark and Germany, where salaries and wages are high, so for the cost of installation is high, BIPV is actually cheaper than on-roof solutions for new buildings. And then as for the first part of your comment, we are actually indeed focused on standard black or blue roofs, but with click on framing, it is very possible to make colored PV roofs as well, which is something we might be doing soon with Futurasan, but they don't make much sense. The efficiency is so much lower and the price is so much higher. Yes.
Mm-hmm. Yeah, maybe I'll contact you when I start with the construction of my to-be newly built home, because I already have a design, and I need a black roof. So, yeah, for now I don't have many comments anymore. So I wish you success with the startup.
Okay, very cool. So just one question to understand. So does that mean you source the modules from the big companies, add then this easy click solution, and then sell the product, right? So do you have actually then also modules in your portfolio that are now these 400 watt plus modules or something like that? So that really there was this big power boost in the last 2 years. So I think one problem in the past was also always for BIPV that it was always too small. It took some time actually, or more time in terms of installation than the big panels. So what are you doing there?
Yeah, with the click-on, it is actually very simple. Usually solar panel frames are 35 by 35 millimeters or 35 by 30. That's kind of like the standard. And we have like about 3 or 4 variations of the click-on, but the size of the panel doesn't matter because we can cut the profiles in any length as we wish. So most common is about like 360 watt solar panels, but we might just as well do 540 watts and higher. We just have to cut the profiles in the right size. It's in that sense, it's very easily scalable. And the profiles we do produce in Estonia, we can fit them to the panel in our factory, but we can also send the frames to the partner, and they can also buy the panels from their local partner or like whoever directly from the producer and fit the profiles themselves. And the tile interlocking module is something we produce in Estonia still ourselves.
And how much more expensive is percentage-wise such a module compared to the standard module?
So the click-on is roughly 30% cheaper.
Cheaper, okay. So because you use a frameless module and add that actually, okay. Or
it's because we use a ready-made panel that is being mass-produced, so we don't have to buy the panels from Europe or make it ourselves, which will make it much more expensive.
Okay, thanks. Okay, super. I think no more questions from my side. I also like it. I was always hoping that BIPV takes off, so hopefully now is the time. So what we should do, since there is no voting today, actually, the voting will take place actually by the participants to the summit. But what we would like to have is from every one of the jury, I think we lost Javier, unfortunately, but I think from Stephan, Angel, I think one recommendation. Who do you think you can actually just give a recommendation, tell why this is your favorite? You can also mention 2 or 3, but please just give some recommendation for the voters. Angel, you want first?
Well, I also would like to ask to remove the slide from the last candidate, because we see that we advertise the company.
Okay, yeah. True. So who wants to first? Or Stephan, you want to start?
Yeah, I can start. I think for me, it's always interesting. I think, Michael, we are doing this now since a few years, and I think we change a bit our view from time to time because we see that the world is so dynamic. So I was never a real friend of BIPV or something like this, but I think we need this now. So I think this is very clear. So at the moment, I'm struggling, even if I'm not a super technologist, with PV2+. Yeah, so I think we need, when we think in terawatt or petawatt in PV, then we need to find a solution for replacing silver. I think this is very clear. And to be honest, I like the solar stone. The concept, I mean, looks good. Let us understand the details. So probably there on the Intersolar. But these are the 2 favorites of mine.
Yeah.
Yeah, so that's probably my turn. So I'm a newcomer in this jury, and Michael, thank you very much for inviting me for this very honorable role. So I don't have any background. I'm not affected by past experiences, so I have a very clear and fresh view on this. And I'm happy that Stephan suggests that you can propose 2 potential winners, because I will do the same. Because I think the general quality of the companies that were selected is really high, and they all have certain, let's say, benefits or eye-opening features. And so I found it really difficult to make a selection. But since we only have 1 minute to announce our preferences, I'll just state immediately that I have a preference for promoting triple solar and solar stone. And I'd like to put emphasis on triple solar because they try to solve a problem that exists in general, namely that we not only use electricity, but also that we need heat, especially in a large part of Northern Europe. And they actually want to solve that problem with solar energy, 100% solar energy. And I thought that our product was very scalable. So personally, I would like to have it. So that's a good indicator for, let's say, probably the reliability of the pitch, or how reliable it seemed. And for Solar Stone, I think I was really clear in my reaction that I find the product aesthetically appealing and suitable for application in the built environment. And also here I thought, yeah, this is a really product I like to have myself. Not only because the pitch was presenting a sort of reliable proposition, but also because I believe that we need click-on, easy installable and affordable solutions for BRPV, and then it will start running.
Great. Yeah, so I find it also very difficult. Because I think we had a nice variety. Actually, I like most of the pitches, or almost all, because I think they were also so tackling different topics. So I think I liked also Over Easy. Actually, they came with this bifacial solution for flat roofs, which you can also combine with grass roofs. I think that's actually nice because a lot of people want to have grass roofs, but then there's no space for solar. I think with this solution, you can do that. It's a little bit like agri-PV on the roof. You have with PV Plus actually something which is important. We need first also some material suppliers if we want to get manufacturing up again in Europe, and I think they have a next-gen solution. I think that's pretty cool. Also, really research done in Europe by one of Europe's leading research institutes. I like it. I also liked actually what Solar Freeze was doing, because I think it seems simple, but I think it's very nice, and they put actually a really cool business model also behind that, actually, so that they make it easy for the people to address this solution, which sounds rather simple. A container with a solar module on it, but I think, and it's really important. If what Disnos actually showed that how much food is actually just going to waste. So we're seeing actually now also that the Ukraine war is creating a problem for us even here with all the wheat production actually being impacted. And then of course we have Solar Stone and Triple Solar, as you said, Angel, that they're really trying to solve the issue with heat, which is the biggest problem. I think electricity is somewhat under control. Actually, it's heat and transport. So okay, who do I like? I would also go pretty much upstream. So I would like to, I would support actually PV2 Plus, next gen contacting solution, always dear to my heart. Also, maybe I'm a bit biased here, the manufacturing sector. And on the other hand, I actually like Over Easy Solar because it's somewhat different actually, and it's special. I think BRPV is also great, and I think they come with a great solution. But I think this is also nice, very lightweight solution, bifacial, addressing also different topics. Okay,
good.
So
thanks.
Cool, and thanks. I think that makes it not easy for the for the voters, because you have all gotten somewhat different recommendations from us. Nevertheless, I think there are 5 great companies to select from, and we wish all of you great luck. Thanks again to Stephan for sponsoring also this award. Thanks, Angel, and also Javier, who we lost, for participating.
Okay, bye.
Have a nice day. Thanks.
Bye.